All right, I hope everybody's having a good day today. We'll get to the focus activity in just a minute. A few reminders. We're going to have that quiz tomorrow over number sets, significant figures, and scientific notation. Okay, so if you have any questions, come on in. I know we're a couple of weeks out, but I want to go ahead and get you to kind of think about this as we approach the first vacation of the school year. On November 21st is when we'll have our first exam. All right, so that'll probably have the material we've been working on recently, the number sets, significant figures, scientific notation. It'll have error approximation on there. And it may or may not have arithmetic sequences and series. We'll see how far we can get, because next week we're not teaching. You're going to have the class period every day next week to work on your internal assessment. And if this applies to anybody, I don't believe anybody in here failed for me the second 6 weeks, but if you're in a weighted course or an upper level class and you happen to have failed for the second 6 weeks, remember tomorrow by noon is when a waiver is due to Mr. Young's secretary. So you can just walk in there and ask for one of those if you need one. Okay, let's take a look at our focus activity. It's not perfectly crisp. I do apologize about that. But let's see here. It says the local health and fitness center recorded the following number of clients per week during the last year. Calculate the average number of clients per week and the standard deviation from this number. So they're giving me a frequency list here. Jacob, would you get that, please? Thank you, sir. And what I want to go ahead and do is figure out the standard deviation and the average of these values. Okay, so if you were to go ahead and generate the entire set, the frequency of 36 is 2, so it would be 36, 36, then 5 39s, 9 44s, and so on. Thank you again, Jacob. All right, so let's go ahead, go to the calculator. I'm going to go to the home screen. There. Okay, so remind me how I would do this. How would I take this frequency table and go ahead and find the standard deviation and the mean? Okay, list and spreadsheets. So I'm going to go to the first one here. Okay. I'm just going to go ahead and title these X and Y, or maybe I'll go ahead and put in frequency this time. Why not? Okay. Remember to avoid this equals row right here. Let's go ahead and put in the actual data. So I have 36, 39, 44, 45, 46, 48, 50, and 52. Okay. Control 7 gets me to the top, where I'm going to put in the frequency. So 2, 5, 9, 11, 15, 5, 4, and 1. Okay. So I've got the data in. Now what? Okay, we're going to go to menu. Statistics, stat calculations. This is one variable because it's a frequency list, okay? One variable, we're going to click OK on that. So I'm going to go ahead and delete this. The X list is the first column of information. Then I'm going to delete that. The frequency list is the second column. Looks like it's going to show up in column D. And here we go. Which one do I take, S of X or sigma X? Sigma X. So to 3 sig figs, let's say 3.28. Okay. And then my mean, it looks like 45. Okay. So 45 and 3.28. All right. Elizabeth, you have a good day. Okay. So the mean was 45 clients, and sigma X was about 3.28. There we go. All right, Laura, you have a good day too. All right, any questions? Okay, do we remember the keystrokes for that? Okay, Ella, you didn't remember the keystrokes? But is it okay now? Yeah. There you go. That's why I'm going to spiral this back in. Well, number 2, it says the lengths of 30 randomly selected 12-day-old babies were measured in the following data obtained. All right, so we have our data divided up into class sets. Estimate the mean length and the standard deviation of the lengths. Now, here's the thing. We want to go ahead and do the same thing we did on number 1, but what do we do if we have our data divided into class intervals instead of the actual numbers themselves? We take the midpoint. Now, even though we're not including 42, I mean, we could go to 41.999 and we could get the specific value. It is okay. We could just go ahead and say 41. Okay. And we're going to go ahead and count the odd values as we go. So this would be 43, 45, 47, 49. Then we have 51, and our final one would be 53. Okay, so I'm going to input that data using the midpoint, just like we did a moment ago. Thank you, Emmy. Jacob is getting up quite a bit. We'll let him rest. Okay, let me go ahead and get out of here. Control W. No, I don't want to save that. Okay, so we're going to go to list and spreadsheets one more time. Okay, this is X. Frequency. All right, so my midpoints, we had 41, 43, 45, 47, 49, 51, and I believe we stopped at 53. Okay, good Lord, that door's busy today. Unfortunately, we can't leave it open because of school policy now. Yeah. All right, so they're back. Okay, we got focus activities up there. Let's see, now the corresponding frequency is 1, 1, 3, 7, 11, 5, and 2. Okay. All right, so how do I find the standard deviation and mean once again? What are my keystrokes? Okay, menu, statistics, static count, one variable, remember, because it's just a frequency list. Okay, and then we're going to delete that. Okay, whoops. Okay, so the first column is my X list. The second column is going to be my frequency list. Again, it's showing up in column D, and here we go. So to 3 sig figs, what should I be getting for my standard deviation? 2.66. And what is my mean? We'll say 48.3. Okay. Because that's a length, so that could definitely be a decimal value. Okay. And what was standard deviation? I mean, what did it do for us? Does anybody remember? The average distance, okay, okay, there you go. It was a measure of spread. Remember, we used it as a descriptor. Okay, good. Good. All right, we'll go ahead and put that to the side someplace safe. We will get focus activity number 2 tomorrow, and then we'll worry about number 3 the week after next. Okay, Control W. All right, so let's get out of here. Okay, so we've been talking quite a bit about error approximation. We've been talking about absolute error, relative error, and percentage error. But I want to go ahead and kind of branch off into a few other little concepts in this lesson. Set builder notation and interval notation. Interval notation is used to denote the boundaries or range of a set of values. A bracket indicates that the endpoint is included. A parentheses indicates that the endpoint is not included. Now, the symbols positive infinity or negative infinity are used to denote sets that may have a side with no endpoints. So if it's has no upward bound or no lower bound, we want to go ahead and use infinity. Okay. So set builder notation, we've seen this briefly, but it's going to be in these squiggly brackets. This is read all X. Does anybody remember the 2-word phrase for that little vertical segment? Such that. There we go. So all values of X such that, and then we have our restriction right here. We see that X can only exist between -3 and 5 with -3 included. So if I were to go ahead and look at the interval notation for this, what you do is you always put a comma between your two values, what's considered your upper and your lower values. Okay. In this case, -3 and +5. And then you use the appropriate symbol to indicate if that value is included in the set or not. Okay, so sometimes it might even look like an ordered pair if you have both parentheses. But let's go ahead and look at this graphically, and that might help. Do you remember making these number lines way back in the day? Okay, well, I'm very interested in numbers -3 and 5. So I'm going to go ahead and put -3 right here. I'm going to put a 5 right here. Now, think about your inequalities. What kind of circle would I place over the -3 since he's included? Yeah, he would be a closed circle. Okay. What about for that 5? Okay, empty, because that indicates that he is not included in the answer. So I can go up to 4.999, but I can't use 5 itself. So I'm looking for all the values of x between these two. Okay. So these are just different representations of the same idea. It's giving you the same information. So when you're thinking about this interval notation here, a closed circle is the same as the brackets, and an open circle is the same as the parentheses. Okay. Well, let's try the next one. The set of all x such that x is less than or equal to -6. Okay. So in this set here, -6 is definitely the upper boundary. So I'm going to go ahead and put comma -6. But we have no lower boundary. So what do I put? -infinity. Now here's the thing. No matter what, you never include infinity, whether positive or negative. It just represents an idea. It's not a specific value. But what would you say about the -6? Bracket or parentheses? Yeah, bracket. The -6 is included because I have equality right here. And there we go. Now, would anybody like me to go ahead and graph these other ones as well? Does that kind of help, or are we okay? Jacob's okay? All right. Everybody else okay? All right. Well, let's try this next one. The set of all x such that x is less than -4 or greater than or equal to 7. Okay. Less than -4 or x is greater than or equal to 7. Now, you'll notice this is two different sets of values. So we're going to go ahead and create an interval notation for each of these. Let's do this one first. X is less than -4. So I'm going to go ahead and put my comma here. Is -4 the upper or the lower boundary? Okay, it's the upper because I want everything less than -4, right? So I'm going to put -4. And just like the previous problem, well, that would be -infinity because there is no lower boundary. Okay, now the -4 is not included. So it, just like the -infinity, I'm going to put a parentheses on there. So this is telling me the same as this old inequality right there. Now, take about 10 seconds if you haven't already done so. Write an interval notation for x greater than or equal to 7. So think to yourself, okay, that's 7. Is it going to be the upper? Is it the lower? What would the other value be? So hopefully a lot of the rest of this is going to be review. If not, that's okay. We're good. Right, Lucas? Okay. Anybody tell me what I should write? What should I put here on the left of the comma? Okay, 7. 7 is the smallest value in this set. How high does it go? To infinity. Okay. Now, we never include infinity no matter what. But what about this 7? Okay, bracket. Now, think back to what we were talking about when we discussed sets. It's this inequality or this one. You remember that keyword or? That was associated with what idea? Union. So if you have multiple interval notations, you just combine them with a union. Okay. So this interval or the second interval. Okay. And then this last one here, the set of all x such that x is greater than 9. So we can go ahead and write that out, the set of all x. Now, instead of the vertical segment, does anybody know what other icon I could use in place of it? Does anybody remember? You can use a colon. Okay, so you can just say ... All right, all values of x such that x is greater than 9. Okay, so there's the solution set. Now, it doesn't say or equal to, it just says x is greater than. All right, so who can tell me what my interval notation should be for this? Should I start with a parentheses or a bracket? Okay, parentheses. What? 9, comma, infinity. Here we go. Okay. Perfect, perfect, perfect. Okay, good. All right, and now we just have some standard units of measurement. The International System of Units is a set of standard units of measurement that are used worldwide. Many of the U.S. measurement units differ from the standard units, so it's important to be able to convert from one unit to another accurately. Okay, time. The base unit of time in SI is the seconds. Unlike most units within the SI system, conversions of time are not based upon powers of 10. They're based on the external influence of the sun, moon, and the Earth's rotation. So we have all these conversions here. 1 minute is 60 seconds. 1 day is 24 hours. Now, this is interesting. It says 1 year is 365 and 1/4 days. Because what happens every 4 years? There's a leap year where you have an extra day in what month? February. Okay, you guys are great. All right. For time less than 1 second, that's when we go ahead and use base 10. Small units of time are becoming more common with the advances in computer technology. 1 microsecond is, what is this? 1 millionth of a second. 1 nanosecond is 1 billionth of a second. Okay. For time greater than 1 year, base 10 is also used. And then we have a decade is 10 years, a century is 100 years, and of course a millennium is 1,000. Now, I've never actually seen one of these problems show up on the paper exam, but it is something we're going to go ahead and practice. Like if I were to go ahead and give you, a time, if I said, okay, 11:36 a.m., and I said, okay, you have an appointment exactly 3 hours and 15 minutes later, you need to go ahead and be able to tell me what time that is. Does that make sense? Just working with a clock, so it's nothing really too difficult. Okay, time zones. What is the time difference between 9:55 a.m. and 1:25 p.m.? Okay, well, time zones, the Earth rotates a full 360 degrees every day, which is 15 degrees every hour or 1 degree every 4 minutes. Places on the same line of longitude share the same true local time. However, using local time would cause problems. For example, some states or counties stretch across almost 15 degrees of longitude. This would mean time differences of up to 1 hour in the same state. So the solution was to create time zones. Now, how many time zones do we have? Well, now, if we're talking in the U.S., there's 4, but I'm talking worldwide. 24 because there's 24 hours in the 1 day, right? But it's really not as simple as that, unfortunately, because not every time zone is in 1 hour shift. There are several time zones that only have a shift of 30 minutes. There are some that only shift 45 minutes. And in fact, can anybody tell me one country that is on the same time zone? Switzerland? No, it is China. It is China. So people can be 3,000 miles apart in the same country. As long as they're in China, it's the same time. So that actually spans across several time zones. So it's not as simple as just I'm from one time zone to the next. It's always going to be adding or subtracting 1 hour. You definitely need to know what the countries are doing. The first line of longitude, 0 degrees, passes through Greenwich near London. The first or prime line, this is what we call the prime meridian, is the starting point for the 12 time zones west of Greenwich and 12 time zones east of Greenwich. Places which lie in the same time zone share the same standard time. Okay, so a little bit of notation here. Time along the prime meridian is called Greenwich Mean Time. That's what GMT stands for. You've probably seen that at some point. Places to the east of the prime meridian are ahead of GMT. Places to the west of the prime meridian are behind GMT. The numbers in the zone show how many hours have to be added or subtracted from Greenwich Mean Time to work out the standard time for that zone. So you got this graph that came with the notes, and I do apologize, it is not the best one that shows up on your paper here. I did go ahead and provide you with a color one that's way better that we're going to go ahead and look at in just a second. But I've highlighted a couple of things here. This first red line right here, this one right here, that's the prime meridian. Okay, that's the prime meridian. So we're going to go ahead and say it starts there from GMT, Greenwich Mean Time. Hello. Okay. And now what we're going to go ahead and do, this is on the direct opposite side of the Earth. And you'll notice this isn't going to be a straight longitude line. This line kind of goes back and forth through the Pacific Ocean, picking up several different items. But right here, this is where the day starts. At the very end here, as the Earth rotates, that's where the day ends. Okay, so depending on where you are on Earth, different places could be on a different day. All right, because they're going to be probably on the other side of the Earth from where we're at. What I'm going to go ahead and do, we want to go ahead and ultimately ask, okay, if it's 11 p.m. on Tuesday in Greenwich, what's the standard time in New York, San Francisco, Brisbane, and Johannesburg. Well, instead of kind of going through this, because we know that certain time zones aren't going to be just the one full hour, okay, what I did, if you go to your Google Class page, if you go ahead and scroll down to this current week right here, I did put a link on there that takes you to the map that I gave you, and it's an interactive map. Okay, so you can actually go ahead and just kind of hover over the dot where the city would be. All of these cities are included, okay, on this particular map. So the first one, we want to know what's the time in New York, right? Okay, well, here's the thing. This map, unfortunately, doesn't have Greenwich, but it does have London, and they are within the same time zone. I'll go ahead and tell you that. So if we go ahead and find London, okay, London's right here. So right now in London, it is 7:57 p.m. It's almost 8 o'clock. Okay, we're wanting to compare that to New York. So let's come on over here to New York. Okay, so right now in New York, it's 2:57 p.m. So how big of a time difference is that? That's 5 hours, right? Okay, so if it's 11 p.m. in Greenwich on a Tuesday, what time would it be in New York? It'd be 6 p.m. on Tuesday. There you go. Okay, does that make sense? Okay. And I'm not going to go ahead and worry about the other examples because I think it would actually be also kind of fun to go and kind of, work with this map yourself. In fact, if you were to go ahead and scroll your mouse over, you'll notice the time zone you're in darkens the countries that are belonging to that. And look what happens when I go over here to China. See, all that's one time zone. Okay. Like right there, China is not in this particular time zone. All right, so I am going to go ahead and write out the answers for the others, and then you can go back and check those. Okay. All right, so we said this was going to be 6 p.m. on a Tuesday. Okay. So San Francisco, if it's 11 p.m. in Greenwich, then it's going to be 3 p.m. on the same day. Then it's going to be 3 p.m. on Tuesday. Okay. And Brisbane, where's Brisbane? Australia. Okay. So because it is east of the prime meridian, okay, that means Brisbane is going to be ahead of them. So, in fact, you're going to find it's ahead 10 hours. So if it's 11 p.m. in Greenwich, what would it be in Brisbane? It would be 9 a.m. Wednesday. Okay. That's kind of trippy, right? If you were like in London and you're talking to somebody in Australia, okay, and it's the next day there, I don't know, that's weird. Okay. And of course, if I'm talking to somebody from Australia, I'd be like, you throw a shrimp on the barbie? The dingo ate your baby. Anyways. And then in Johannesburg, they are 2 hours ahead, so it should be 1 a.m. on a Wednesday. Okay. There we go. Now, I didn't mention this a second ago, but this right here, the other longitude line where the day begins and the day ends, depending on what side you're on, okay, that's what we call the international date line. And it actually does change rather frequently. Okay. But that's still pretty interesting. Like I said, take a few minutes tonight. Go ahead, click on that link. It really is fun if you start looking at it. And then you can go ahead and start comparing like other cities to where we are. Okay. All right. Good, good, good. Well, we don't have a whole lot left. Really, we just got conversions, a few solving equations. The two most commonly used scales to measure temperature are degrees Celsius and degrees Fahrenheit. So if I want to go from Celsius to Fahrenheit, F equals 9/5 C plus 32. Or if I want to go Fahrenheit to degrees Celsius, 5/9 times the difference of Fahrenheit and 32. I'm sure at some point you guys have used those like in algebra. Do you recognize those? Chemistry? There you go. Okay. So this one says convert 70 degrees Celsius to Fahrenheit. So I want to use this formula right here. So the Fahrenheit is going to equal 9/5 times the 70 degrees Celsius. Okay. Plus 32. All right. So we could go ahead and just multiply and simplify. I prefer to go ahead and multiply ahead of time. How many times will 1 divide into the 70? 14. Now I need 14 times 9 plus 32. So that is 126 plus the 32. 158. So this will be 158 degrees Fahrenheit. Okay, so that is, really straightforward. Just substitution, simplifying an equation, nothing to that. Okay, and then you've got the Celsius and the Fahrenheit table over here where water freezes and boils. Okay, all that good stuff that we know from science. All right, imperial standard units. Okay, metric system. It's based upon the decimal system and is now used in most countries of the world. The imperial standard units were established in 1824 in England. This set of units was only one of many used throughout the world and is still used by some countries, including the U.S. Okay, so you have all kinds of conversions for length, for weight. Okay, so using some of these conversions, why don't we go ahead and answer these questions. How many miles is a 5-kilometer run? Okay. So we could kind of do this one of two ways. We could go ahead and set up a proportion, okay, or we could just go ahead and look at it, what we refer to as dimensional analysis, when we're just converting the units. Okay. Well, does anybody have a preference, or you just want me to choose one? Choose one. Okay. So let's say I have 5 kilometers. Okay, and I want to know how many miles that is. Well, I'm going to go ahead and multiply that by a ratio. In order for the kilometers to cancel, where do I need to put them? They have to be on the bottom. So kilometers, and I want to end up with miles. Okay. So now I'm looking at my table up here. How many kilometers are in 1 mile? Okay, and how would I want to go ahead and do this? Would I want to go ahead and put, well, okay, we could do it like that. Okay. So 1 kilometer is, what's that? What? Oh, I was looking at that one. I was like, why isn't he saying 1.62? Yeah, 0.617. There we go. So 1 kilometer is going to be 0.617 miles. Okay. Or you could even use the other one, the 1 mile over the 1.62, which is what I was originally thinking of, and it's still going to work out the same way. So I'm going to come on over here, calculator. So we have 5 times, what was it again? 0.617? Okay. So I'm thinking about 3.085 miles. Okay. And if I wanted to put that in 3 sig figs, I could say 3.09. I'm not too worried about it now. And remember, you could also go ahead and use a proportion if you wanted to, instead of just straight converting it. Let's try that on the next one. How much do you weigh in pounds if you are 72 kilograms? Okay, anybody want to come on up and show me what this proportion would be? All we want are 2 ratios of kilograms to pounds, or you could even do pounds to kilograms if that's what you want. So many hands going up. I don't know how I'm going to choose. Okay. Hey, what time's that game start tomorrow night? Does anybody know? My sister and I were going to head out there to the Spurs game. What time is it? Jaylee, you said 7? Jaylee! How many people knew what I was doing? Hey, I'm getting too predictable. All right, so Jaylee, I need you to convert 72 kilograms to pounds. Oh, yeah, go. And Maddie, same thing. Okay, so 72 kilograms.
Ah.
Okay. And somebody help her out because now she's just looking at me. 72 times 2.20 pounds.
Oh, wait. Sorry, what was it? I don't have a calculator.
158.4.
That's how we do it in chemistry.
And that's pounds. I've never seen it done that way. That's cool.
Like in chemistry, to keep all the like moles and stuff, you have to like put all of them.
Yeah. Okay, cool, cool. Does anybody want me to go ahead and write out the proportion? Would anybody like to see that? Sure. Okay. Well, we're trying to change kilograms to pounds. So 72 kilograms. What?
Oh, sorry.
What's that?
I did it wrong.
No, you just didn't put pounds. I mean, your answer is perfect. Okay. Equals. Now I want to go ahead and set up a ratio here. So we know that 1 kilogram is approximately 2.20 pounds. There you go. And you'll notice the way Jaylee set it up, we multiplied the 2. Well, in order to solve a proportion, you would cross multiply here 72 times, again, the 2.20. There you go. So, I mean, however it's most comfortable for you, I would encourage you to go ahead and do that. But there you go. Okay. And we had just enough time. It's 2:07. Okay. So we will have our second focus activity tomorrow. If you weren't here yesterday, make sure to grab yourself a copy of the homework. We should have several left over here. The homework is due tomorrow. We'll talk about that. And then we'll go ahead and finish up with our quiz on number sets, significant figures, and scientific notation. Okay. Thank you very much, guys.